NCBM 0324, Section 1.6, Completing the Square, Part 2. So we've practiced a few times with this new process, finding that value for b that's going to make it all work out nicely. But in those examples, we had a coefficient of 1. We didn't have to factor anything out at the very beginning. What happens if I do have some other coefficient? Looking at example 2, I want to complete the square again. But for part A, I have f of x is equal to negative x squared minus 2x plus 5. So notice the difference here is I now have a negative in front of my x squared. To start though, we're going to begin in the same place. We're going to group our x terms together, the values that have an x in them. So negative x squared minus 2x, leave some space. We're going to fill that in, and the plus 5 is on the outside. So here's where we're going to put a little extra step here. This is where our process has changed slightly. Because of that negative in front of my x squared, think of it as a negative 1. I don't want that negative 1. I want a nice positive x squared in my parentheses. So that negative x1, I'm going to have to factor it to the outside. So when I factor out negative 1 from everything inside of my parentheses, I can write the negative 1 on the outside. Then left over inside, I'm going to have a positive x squared plus 2x. So how did that change to a positive from a negative? Well, remember, we're factoring out, we're undoing that multiplication of the negative through. So it factors out to a positive 2x inside. And now it looks like our previous example. So again, from our last steps, we're going to take this number, just the number, that is equal to 2 times our b value. And again, we're always going to we end up actually taking this number and just simply dividing it by 2. That gives us a 1 here, but I also need the square of that value. And 1 squared is still 1. So our next step, we're going to add 1 on the inside. That's going to make the factoring work out as we want it to. Usually, right, after we add on the inside, we would say we'd have to subtract on the outside. We want to make up for the change in the function that we did by adding that 1. But here's another change, another thing to consider. When I say I add 1, that's inside my parentheses, but what's in front of the parentheses is a negative. So what I'm really doing is adding 1 times this negative value in front here. So 1 times that negative 1. So if I need to subtract that, I need to subtract exactly that same calculation. So I'm going to say minus negative 1 times the 1 from the inside here. Or if that's a little confusing there, you can also think of this as I'm not really adding 1 on the inside, I'm really subtracting because of that sign, because of the negative in front. So if I'm subtracting that number, then how do I make up for it? I'm going to add it on the outside. But be careful, right? It may seem like I'm adding and adding, but you have to also consider the number in the front, right? That sign that we have that would eventually be distributed through. So either way, we end up with a plus 1. So when I write this out, right, I'm going to have x squared inside plus 2x plus 1 plus 6 out there, outside of the parentheses. And when I factor it out, I'm going to have x times x, 2 numbers multiply to give me 1, but add to be 2. Well, it's this 1 that we built, right? We actually made that happen, plus that 6. So my final form, I could say negative x plus 1 squared plus 6. And there's our new form. So negatives, signs, just like any other time we work with a negative value, we got to pay a little more attention to it. It calls for a little more attention just to make sure we're using things in the right way. Let's try that again. Let's try out part B. In part B, we have a negative x squared minus 10x plus 15. So the initial steps, right, you can start to see a pattern for these steps. We're going to group the terms of our function that have a variable together. The constant will be on the outside. Then I'm going to factor out that negative sign because I don't want a negative x squared. I want this to be a positive x squared. That's the only way I can work with this completing the square business. So that's going to turn the values on the inside x squared plus 10x. The minus came forward. And then the 15 is just kind of being copied along. Now comes the process of completing the square. I know that this middle number is 2 times the value that I really need. So I'm going to take that number and I'm going to divide it by 2. It's always divided by 2. And I end up with a b value of 5. But I also need to know that number squared. So 5 squared gives me 25. So 25 is going to make the factoring as I want it to be. But if I'm adding 25 inside with the minus over here, it's really like I'm subtracting 25. So then to make up for that, I'm going to add 25 on the outside as well. Or if you want to see it in the other way, right, if I add 25 here, I'm really adding 25 times negative 1. So I'd have to subtract that negative 1 times 25. And you can see how the negative and the negative ends up turning positive anyways. Right? So we do the same thing, however we like to view it. From that point, let's start simplifying this. I'm going to have x squared plus 10x plus 25 plus 40. And of course, the negative still in the front of those parentheses. And you might feel ready now, but just in case, just one more time, factoring out this trinomial that we built, we get x times x for the x squared, 2 numbers that multiply to give me 25 but add to be 10, is that 5, right? It's always that b value. So there it is. Our function in this new form is negative x plus 5 squared, right? That's in parentheses, plus 40. And there is our answer. Now something to consider, right? If you are still a little uncertain of the process and if you're doing it correctly, how can we check our answer? How can we make sure that we divided correctly, we factored correctly, all of those steps that we took? Well, if I start with this form, with my vertex form, how can I make it look like my original? Well, to do that, I would have to take my x plus 5 squared and multiply it out. I would do the opposite of the factoring, and I would multiply everything through. So I'd have x squared plus 5x plus another 5x plus 25, and then the 40 is still kind of tagging along. And at this point, I would distribute the negative all the way through, combine like terms, and I'd have negative x squared minus 10x minus 25. I combined these into 10x and the negative went through. And I still have that 40 outside. Well, there's no more outside if I get rid of the parentheses. And one more combining of like terms. Negative 25 plus 40 gives me that 15. So we can see how they end up matching, right? In either direction, they're going to end up in the same place. So that's a good way of checking. If you're a little uncertain, the numbers look a little weird or just don't feel right, try multiplying it out. See, does it work out where you end up where you started?